Hello everyone. Today I'm gonna be talking about sections 12.4 to 12.6. We will continue on talking about vectors and some surface in three-dimensional space. So before we start about cross product, let me recall something about the dot product. Say we have two vectors. U is ABC, three components, right? And then V is X, Y, Z. So we dot the two vectors, U dot V. We multiply those number of components y, so A times X, B times Y, and C times Z, then we add them up. We ended up with a number, okay? In here, order doesn't matter. You can take U dot V or V dot U, you're gonna have the same value, which is a number. And we talk about the angle between the two vectors. And we can calculate cosine of that angle by U dot V divided by magnitude of U times magnitude of V. That was what we learned on previous section 12.3. So give you a recall before we move on. Today we're going to be talking about the cross product. So instead of denoted by a dot, that was cross. So let's select an X. Now we denoted by U cross V. This is cross product. And unlike the dot product giving you back a number, cross product going to give you back a vector. So I'm drawing the picture right here. You got a vector U this way. You got a vector V this way. If you take U cross V, it's going to follow the right hand rules right here. U cross V, and you got a vector W pointing to the direction of your thumb. Okay, U and then V up. So actually in here, order does matter. So start with U, you go in this direction. You got U, go V, and you got W. What if you do V cross U? Now V first, cross U, you got to go this way. So it's going to follow this way. V, from here, go to the U direction. You're going to have the opposite of W, we denoted by negative W. Okay? So U cross V is going to be the opposite of V cross U. And the product is going to give you back a vector. It's not a number anymore. Okay? That's what the geometric interpretation of the cross product, I'm sorry. Now let's talk about calculation. You got U cross V, right? So this is how we define it. But before we define, let's recall something about matrix and determination of the matrix. It will be easier for us to write it down. But I'm going to use the same numbers. U is A, B, C, and V is X, Y, Z. Okay? So this is how I usually do to calculate the cross product of two vectors. So I, J, K, I represent the X direction, J is the unit vector for the Y direction, and K is for the Z direction. And U is what? A, B, C, right? And then V is X, Y, Z. So the cross product will give you back a vector. This is the definition from the book, and then I'll explain to you how we think of it. So for the I term, the first term, the X coordinate, you delete the I column, okay? You have what? B, C, Y, Z, okay? So determinant of this is a 2 by 2 matrix, B times Z minus Y times C. So the first number is going to be B times Z minus C times Y will be the first number. Let me write a little bit smaller so I have enough room to write. BZ minus CY. That's the first number. Okay. And then for the J term, all right, think A times Z minus X times C, but the opposite of it. So X times C or C times X. C times X minus A times Z. Okay. And for the K term, you have what? Delete the K column. You got A times Y minus B times X. And this is the definition of the cross product that the book gave you. Okay? And let me explain to you how you're gonna get it without really memorize a lot of things. Actually, there are many ways for us to get this. The way that I usually do, I bring it back to pre-calculus algebra that we learn about the determinant of the matrix. So recall the matrix determinant of the matrix. Okay? I got a 2 by 2 matrix, say A, B, C, D. You took pre-calculus algebra, right? So let's go. This is matrix A. So determinant of A. Many books denote it this way, or denote it this way: A, B, C, D with the absolute value, and this determinant is calculated by what? A times D minus B times C. Major diagonal subtract a minor diagonal. That's determinant of matrix. This is 2 by 2 matrix. Okay? And the cross product is like determinant of a 3 by 3 matrix. Just go back to 2 by 2. So the first row is I, J, K with the 3 components, coordinates of x coordinate, y coordinate, and z coordinate. And then I list the 2 vectors in the right order. And U first, or U is the second row, A, B, C. And then V after. So V is x, y, z. So if you got what? V cross U, you better